Okay, so today we're going to do conditional probabilities, and we've done some of this before, but we've done them with tables. If you remember some of these conditional probabilities, they look like this. The probability of A given that event B happened. And if you remember how we kind of did this, we kind of said, oh, this is kind of like A and B over B, because our total sample space wasn't everything anymore. Our total sample space was just B. So it's very, very similar when we have a table, but when we have a tree diagram, because there's more information, but it's not too hard to do. So we're going to try this today. So here's the first thing we're going to do. We're going to kind of read through, and I've already circled some of the stuff that's important. But basically, they're testing Olympic athletes for drugs. And so say 2% of the Olympic athletes did drugs, and 98% didn't do drugs. And then say 1% had a false positive, and a false positive means that they weren't doing drugs, but the drug test said they were. And let's say 5% had a false negative, which means they were doing drugs, but they didn't get caught. So we're going to figure out what the probability that an athlete who tested positive actually took drugs. So it's kind of our conditional probability we're trying to find is the probability that they're positive, or that they're on drugs. So they're on drugs given that they're positive. Okay, so our sample space is only the amount of athletes that tested positive. So we're going to make a tree to try to model this situation. And I need a lot of space for my tree, so that's why I'm kind of going down further. And so we can say, let's call these people the drug people, and these people the non-drug people. Let's say we have 2 or 0.02 here and 0.98 over here. Okay. Now there's two options that could happen from here. One option, they test positive. Second option, they're negative. Same thing for these guys. Positive, negative. Okay. So if they're actually doing drugs, they have a 0.5% chance of not getting caught. So that'd be 0.005, which means they have a 0.995 chance of actually getting caught. Okay. If they didn't do drugs, they have a 1% chance of it telling them that they did, and a 99% chance of saying they didn't. So the first thing that we want to do is we want to figure out how many people would have tested positive. So the percent of people that would have tested positive would be this right here, and this right here. That's how many people tested positive. That's going to be the bottom of our fraction bar. And so if we do that, that would be 0.02 times 0.995, so about 2%, and then 0.98 times 0.01, so about 1%, so about 3% in all. We could round these things, but it's about 0.03. So that's how many total people tested positive. Now let's figure out the people. So we got to go back up and see who we wanted. We wanted the people who actually did drugs. So the people that actually did drugs would just be, this amount right here. This amount's not included because they didn't test positive, so we just need that amount. So we would have to do 0.002 times 0.995, and that again is about 0.02. So then when we do this, it's about 66%. Or 67 if you want to round up, because that's 6 repeating. So 67%. Okay. So that's kind of how these tree diagrams go with these conditional probabilities. What you want to do first is you want to make your tree diagram, and then you need to find all the people that fit your requirement for this portion. So the first thing you have to do is you have to find your bottom portion. Then you're just going to look for the overlap to find your top. And after you do that, you take what you want over your total sample space, like any probability, and find your percentage. So lots of things are going to work this way today. Please ask me any questions if you have any, and try these types of problems.